In this section on real-world applications and interpreting graphs, we will be able to investigate and analyze functions and their characteristics graphically, including domain and range, intercepts, and zeros. Let's take a look at situation number 1. Larry made a scatter plot showing the apparent height of a football at 1 second intervals during the time period the ball was in the air. So the time period that the ball was in the air. So Larry is throwing the ball. Time in seconds is our independent variable, the x-axis. The height in feet of the ball is the dependent variable, the y-axis. The scatter plot means it's just points of data that are taken at each of these intervals. Notice that the ball starts up here at 6 feet. The ball does not start at the ground. Let's answer the following questions using the scatter plot above, this scatter plot. What are the lowest and highest values in the domain? I see domain, I think x. The lowest and the highest. Lowest is least, highest is greatest. So in the domain, the lowest is 0, the highest is 5 and a half. Notice that if this is 4 and this is 5, this has to be halfway. So each block is a half. So this is the greatest, which is 5.5. So the least is 0 and the greatest is 5.5. What are the lowest, the least, and the highest, the greatest, values in the range? I remember the range means y, so now I'm looking at the y-axis. The lowest that it goes is here, which is 6. The highest that it goes, where's the highest point? Here's the highest point, so I'm going to look over here. That looks like right here at 13. So the lowest, 6, the highest, 13. Does the scatter plot represent a function, y or y not? Well, if I'm looking at each point, I don't see any other point above or below. Essentially, I'm doing the vertical line test at every point. Do I see any points above or below any of the other points? No, I don't. I've tested every one. So yes, it represents a function because it passes the vertical line test. Using a way to describe it in this scenario, the ball is only at one height at each time, at each point in time. Let's say it that way. The ball is only at one height at each point in time. Let's take a look at another. At what height is the ball at time 0? What is this called? So at time 0, I'm looking for the height, and I see up here, there's the point I'm looking for, 6 feet. So it's at 6 feet. This is called, where it crosses the y-axis, this is called the y-intercept because it's crossing the y-axis, or it's touching the y-axis at that point. Let's look at a few more. How long is a question about time. Is the ball increasing in height? Increasing, so we know that means going up. So increasing in height. So if I look at these and I see the points connected, they're going up, 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 then they start to come down. How long is that? 0, 1, 2, 3 seconds. It goes for 3 seconds up. So I'm going to write 3 seconds. We always use units to describe a real life scenario. Next, how long is the ball in the air? So again, how long is time in the air? Well, from the moment that he lets go, he's throwing the ball until the time that it's caught by another player, perhaps. So all of this time it's in the air, 5.5 seconds. At what time is the ball 9 feet high? So I'm going to the height of 9 feet. That's approximately right there. And I see here's a point and here's a point. There are two places, 2 points in time where the ball is at 9 feet, at 1 second and at 5 seconds. So 1 second and 5 seconds at 2 points in time. At what time is the ball at its maximum height? Maximum is its highest. The highest is right here. That's at time 3 seconds. To continue with that question, what is the maximum height of the ball? Again, looking at that highest point, that's at approximately 13 feet. 13 feet is the maximum height it reaches at 3 seconds. Does this scatter plot have any zeros? What is a zero? That's an x-intercept. Any places where this graph crosses the x-axis? No, there's not. So no, there aren't any zeros because the graph does not cross or touch the x-axis. What does that mean about the ball? What is the x-axis representing? This right here represents the ground. Does the ball ever hit the ground? Nope. So I could also say the ball does not hit the ground. It is thrown from one player to another player. Here are some verbs that are used to describe the changes commonly seen on graphs. Going up, we can say rise or climb or soar or increase. Going down, we can say decline or drop or decrease. Going up and down, fluctuate. Reaching the highest level is peak. Let's take a look at another situation and use our words to describe what's happening in this scenario. Between the years 1990 and 1999, the number of tadpoles in a pond was measured. Here's a graph that represents that. See, the year is on the x-axis. The number of tadpoles is on the y-axis. Use the descriptive words above to help complete some of the sentences. In the year 1990, tadpole populations began to, so 1990, looking at 1990, began to do what? Well, I see they're going up, so I can say increase rapidly. I could have said rise or climb. Increase is also a good choice. Maybe you pause the video and see if you can fill out these and come back and check how you did. Tadpole populations reached in 1992. So I'm going to look at 1992 and I see that's a high point. So they reached a peak, that's the highest level, is the peak in 1992. Between 1992 and 1993, populations of tadpoles. So let's look between 92 and 93. Here's 92 and 93. This section right here, what is the graph doing? Well, I could say, because the graph is going down, decline or drop or decrease. Because it's going down so sharply, I'm going to pick drop. So the tadpole population dropped because it's a sharp drop, going down very quickly. Let's take a look at a few more. Between 1995 and 1999, populations, here's 1995 and 1999. So I see it's going up and then I see it's coming down. So between these years, going up and going down is fluctuate. So between those years, the populations fluctuated. How many tadpoles were in the pond at its highest point? So again, its highest point is right here. How many tadpoles is that? If this is 1,200 and this is 1,600, right in between would be 1,400, but it's right in between 1,400 and 1,600, so that's 1,500. Next, how many tadpoles were present in the pond in 1998? Here's 1998. I go up, I see right there, and I go across to the y-axis. That looks like between 400 and 800, which is 600 tadpoles. And finally, between 1998 and 1999, tadpole populations, 98 to 99, I see that they're going down, so I might say decreased. Other good words for decreased, decline, drop, although drop is more of a sharp decrease. Take a moment to write a short summary. How are graphs useful in describing situations? See you in class.